Today's topic will be, we continue from where we stopped on on Tuesday, interrupt. Interrupt. So we continue from where we stopped on Tuesday. We continue on the same topic, interrupt. There are a couple of slides that going to be slightly more technical this morning, but it is not new. It is not new that most of these topics have been discussed. I'm very sure your operating system lecturer, introduction to operating system in your diploma program, or in FIT, for example, or any other program, diploma in IT, would have covered this up to certain levels. So what I'm going to do today here is go through with you again what is interrupt. As I explained to you on Tuesday, interrupt is a very important operation in operating system, not only at PC level, but at server level, it plays more critical function. Reason, server will be handling hundreds of users, especially your server like MS Windows, Windows servers, Linux servers, or your Unix servers will be handling hundreds or thousands of users. So all these users will be requesting for a service. So when you write your statement in the exam, because this is only written exam, 100% written exam for 2+0 student, no other papers as far as I know. There is a one written exam paper in the 3+0. Other than that, this is only 100% exam from UOG. So you guys are considered very lucky. Yeah? The rest of the papers all 100% coursework. So when you write any statement in your exam, please write specifically, clearly, and complete. So you cannot just simply say request. You must write request for service. Or you can even mention a very specific request for what service. So when user requests for interrupt service, or when user requests for a service to be served by the operating system, by the computer system. For example, I request to change display. Yeah, like what I'm going to do now. I request for a change of display. I request for some service from the operating system. This is an example of request. Yeah, an example of request. So every character or every function or every button that you press on your keyboard or you click on your mouse is actually you're requesting for a service from the operating system. So that is how your operating system is designed. So where this request will go to, this request will go to the control unit. Yeah, the control unit, because it's like our brain. So the control will go to the control unit. The control unit will take a look at the request. Hey, what request is this? Is it F1, F2, F3? Is it shift F5? Because every request, remember I told you there is a number, request number, request ID. The system knows exactly what to do. End of the day, those who understand programming very well, every function, every button, every request on your keyboard is actually executed with a program in your operating system. For example, when you press F1, there is a program will be executed. When you press F2, there will be a program executed. When you press alternate control button, alternate control delete button, there will be a program executed. What is the function of this program? It's a very specific function to be executed. So CU, control unit, will take a look, will analyze the request and do the task accordingly. And so that's the reason why control unit is managing it, so that control unit can assign to the right I/O controller, yeah, to do the tasks accordingly. Provides control for the I/O. Example like what I mentioned to you on Tuesday: unexpected input, abnormal situation, illegal interaction, or most of the time we do legal interaction like multitasking, multi-processing, and so on. So when come to interrupt technology or terminology, I already explained to you last week that there are interrupt number where the OS will be using to identify each type of the interrupt and handle it accordingly. So that is what we call interrupt request. And there is a software which I just mentioned to all of you, which is known as a interrupt handler. It is actually a program that serves the interrupt, also known as interrupt routine or device driver. Yeah, device driver. So for every request, there is a program built in by Microsoft or any particular operating system provider, either it is IBM OS, Android OS, or iOS OS by the developer, and it is known as a device driver. Of course, for Google, there will be a different device driver. For iOS, there will be a different device driver. For Microsoft, there will be a different device driver. For Linux, it will be a different device driver. For Unix, it will be a different device driver. For different types of Unix platform like QNX, yeah, for example, one example will be a different device driver. So just imagine the number of opportunities that you guys have to work in IT field. That is the beauty about IT. Compared to any other fields, we have so many platforms, so many devices, so many areas that if you guys are not very sure, please check with me or you can check with your local tutor. Hey, what exactly you can major in, what you can work as, yeah, even as a programmer, even as a software programmer, hardcore programmer, device programmer, firmware programmer. There are so many responsibilities that you can work as with big companies. Actually, there are a lot of potential that we guys don't know. Maybe you should request, you guys should request for your school to have a career talk or to have what we call opportunities in IT. What are the careers that you can work with, especially when come to the companies like Intel, Motorola, AMD, Hitachi, yeah, semiconductor companies. Where I'm from, I work in Sultera for many years. Uh, those Kulim guys, you know Sultera very well. Penang guys, I stayed in Kulim for 9 years. I work in Sultera for almost 9 years, and then I moved to Johor to work in Seagate. So I'm quite familiar with semiconductor industries, hard disk industries, chip based like what Intel is doing, AMD, and then also I have exposed myself to solar power. Yeah, we have our own first solar company in Sarawak, and then also sun power in Malacca. Then I also have been exposed to MEMC, yeah, another semiconductor companies in KL and in Ipoh. So there are a lot of opportunities for you guys to work. There are a lot of opportunities that unknown to IT guys. Don't think that you only can work in a software house. When I was the head of department in semiconductor companies, I used to have 20 to 30 engineers working for me, and they hold a different responsibility. So when come to networking and operating system, we need a lot of people. We need a lot of youngsters. So I have hired hundreds of engineers, mainly for software, because we develop a lot of softwares. Yeah, we develop all kind of softwares for all the tools in the manufacturing environment. I'm not very sure you're familiar with manufacturing. So in manufacturing, we have hundreds of tools performing different function. So we need to develop a lot of low-level programming. We call it uh, integrated equipment or IE. So we have to develop a lot of software at device level to manage, to control the tools to perform tasks very specific to the manufacturing requirement. Those uncles and aunties or your friends, brothers and sisters working in Intel for Penang guys, KL guys, uh, you will know. You can go and talk to them. The IT department in semiconductor is very big actually, and in semiconductor we don't call IT, we call SIM, CIM, Computer Integrated Manufacturing. The SIM department is what we call the heart of the manufacturing. Without the SIM system, the manufacturing doesn't work even a minute, even a second. So if the SIM system is down, the entire factory will be down. There is no way to do manually. Very difficult, very challenging, and the cost is very high, very very high if the system is down. Don't imagine, like when I was in Sultara, we used to calculate how much is the downtime. 1 hour downtime if your system is down. The 1 hour downtime can run into hundreds of thousand US dollars. So we cannot afford to down the system. So you always must have a backup, hot backup all the time. So that's how it is important. And working in a semiconductor, you will be very well paid, very well paid. And the other opportunity that you will have when you work in a semiconductor companies, reason all the semiconductor companies are worldwide based, they are MNC company. They are not Malaysian based except Sultara. Sultara is a Malaysian based company. So if you work with Intel, you work with AMD, the other opportunity that you have is you can travel around the world. Yeah. I have my team in Ireland, in Italy, in US, the HQ, in Taiwan, in Japan, and in Malaysia. So we have opportunity to communicate with all these people on weekly basis, daily basis, exchange ideas, exchange technology, exchange program. So that's how we work. That is the beauty. So don't think small, think big, think very big that you want to work in an MNC company. I have many students working in Intel where they travel, yeah, overseas frequently. So that is another advantage when you work in IT. So those who are not very sure, hey, what am I going to do after I graduate, or where to specialize in, or what to look for, you please either you talk to your local lecturer or you come back to me. I have a lot of sharing that I can share with you guys. All right. Sorry for taking all of you away this morning. I just want to keep you awake. How beautiful is IT? And moving forward, it's going to be everything IT. Yeah, everything IT. Everybody is talking about IT, from the prime minister right to all the ministers. Yeah? They are talking about Internet of Things. They're talking about big data. They're talking about IR4. So we will be exposed. We will be in demand for many, many years to come. So with that, let me move into slightly more technical topic for this morning. So what we're going to cover is we're going to cover number of registers. As registers are very important component in the operating system, and we will see how these registers controls and perform its function when come to interrupt handling. Yeah, interrupt. Okay, as I shared with you guys on Tuesday, this is the so-called interrupt cycle. There are two important components. One is known as a fetch and execute. The other one is known as a interrupt cycle. So everything will get started. fetch the instruction or the next instruction from the RAM, from the memory, and then execute that cycle. Where you execute in the CPU. You fetch from the RAM memory, you execute in the CPU under the control of CU. Everything has to happen under the control of CU. It's the same like what we do. We read, we execute, right? We as human being, we read, we execute. That's how robot also does. Robot receive the signal through the sensor, yeah, and then it execute. For example, your car, all the luxurious car today comes with thousands of sensors. Like for example, BMW or Audi, it is the new one, the new one. You just need to go under the boot. You shake your leg left and right, the bonnet will open by itself, isn't it? For example, when you carry things on both your hands, yeah, when you carry things on both your hand and you unable to take the key to open the bonnet, for example, as long as your key is in your pocket, you go behind the car, you shake your leg left and right. At the bottom of the bonnet will open automatically. How it happens? Because there is a sensor. The sensor understand there is a key in the pocket nearby, within the area, within the scope, within the target area, within the reach by the sensor, and then the bonnet will open automatically. So that's how it fetch the instruction and execute. Yeah, execute by the system, OS system in the car. And then check for interrupt. For example, before open the bonnet, is there anything else
Anything
that I
else
got?
that I got?
Yeah, anything. Then check for interrupt. That means before the car open the bonnet, the sensor will check. Is there anything else that the sensor need to check or other sensors need to check before
Sir,
execute the task? So
sir,
if there is no other interrupt, then the process will continue with the interrupt, with the request. Interrupt also we can consider as a request, isn't it? Continue with the request, and then the thing complete. So that's how every cycle will take place in your system. This thing is a standard. It's a very general cycle, very high level, not detailed. So you can use this for any function or any request that you want to explain for your exam. But moving forward in the next coming up slides, we're going to have more detail, more detail interrupt, more detail interrupt. So next, let's look at the next slide, servicing the interrupt. I remember I did mention about priority during the Tuesday class. Lower priority interrupt are held until higher priority interrupts are complete. So that is common, isn't it? That is very common. Whichever has higher priority will get done first compared to whichever has lower priority. That's how it works. In the computer system, those who have learning OS, that's why OS is my favorite subject. OS is very important. If you student, you don't understand OS, you will not be a good programmer. You must understand very low level how the system works, how the hardware works, how the priority works, how the interrupt works. When you understand all this, you can be a very good programmer. That's the reason why this hardcore, low level programmer, Java programmer, Python programmer, they pay a lot of concern to the hardware, because every operation that you do, actually you're dealing with the hardware, how your hard disk is accessed, how frequent your hard disk is written, how frequent you are reading your hard disk, because all that will slow down your program. But very shallow knowledge student, no, you don't think about all this. You just write your program and execute, and ended up your program will work very slow. So later when you troubleshoot, you don't know what is causing your program is bad in performance. Then based on priority, yeah? So interrupt works based on priority. Suspend program in progress. Suspend program in progress. So when there is a higher level priority, it will stop the rest of the program, and any other running program will be suspended because the higher priority program need to be executed first. So upon completion of the tasks of the higher priority program, then the next program in the list will run. So I did share with all of you guys on Tuesday what is PCB block, process control block. So all these priorities and all these processes or processes running, yeah, or program in progress, every single one will be saved in PCB block or in the stack area in memory. Yeah, I saw some of you type stack area in the memory when I asked you all the question. Huh? Yes, that is good. So all this will be saved in a memory, which is known as a PCB. And then the OS will just refer to the PCB to execute what is the next process to execute. And if there is a request to branch out, yeah, branch out to another program, it will be done accordingly. It's the same like you write a program and then your program need to branch out. It follows the flow until completion, So there will be many interrupt in the system, and definitely all these interrupt need to be supported by IO devices. Yeah, IO devices such as your screen, such as your USB port, such as your printer, scanner, maybe your external hard disk. All these devices will be used along the way. It depends on what is the interrupt and what task you need to do. Yeah, that's how it works. It depends on your request. Request coming back to the servicing task or request. And for each one of these interrupt or requests, there will be a program. There will be a program, we call it interrupt handling program, also known as device driver. Yeah, device driver. And as I told you, and most of you are familiar with this, you guys can find these device drivers in your setting of your device. For example, you look at keyboard, there will be one device driver. You look at mouse, there will be one device driver. You look at your hard disk, there will be one device driver. That's how it works, huh? All right, moving slightly into more detail. An example, how program A is executing. Okay, give me a minute. Huh? Let me quickly check with the meeting minutes. Hopefully everyone is awake still with me. Make sure no message because I unable to see a message if there is a message. Huh?
Yep, I'm awake.
Okay. All right. Let me continue. Looks like everything is good. All right. So we're going to discuss one example, how program A is being executed. This is a very high level program, huh? Not very detailed. You want a detailed program, you can always refer to your actual assembly language program, like what we discussed in chapter 2, LMC. We will be doing that again during the revision. Uh, Otherwise, this kind of high level programs are good enough for your answers in your exam paper. Yeah, don't worry. I have marked your papers for many years, for the past, I think, 4 to 5 years. So I'm very familiar. And just to share with you guys, I don't know about Penang and Subang. In KL, I was the only lecturer from day one until today teaching this subject. and marking this paper. So far, I don't receive or I don't get any so-called negative feedback or even mark reduction from UOG. So whatever I recommend, whatever I mark, they accept. So I'm quite happy with that. So let's move on with that. And just to share with you, I have student got 98 marks for this paper, 90. Uh, and also I have student who fail, even 16 or 15 marks for this paper. I can share all those papers with you. I have some samples. This paper is not difficult because as you guys can see, it is very basic. I have student finishing this paper in 20 minutes, and I have student finishing this paper in 2 hours. You don't need 3 hours, I believe. 2 hours is more than enough. If you understand, it's a very interesting paper actually, OS. Even though you might find it is very theoretical, but it's up to you how you apply it in your programming skill. Like what I mentioned earlier, as a good programmer, you need to have very good understanding on all this. All right, let's take a look at how a program getting executed with the servicing to service an interrupt. So let me run through that sequence. Number one, before interrupt arrive. That means before interrupt. Program A is executing. Okay, let me use my mouse. I hope all of you can see my mouse. So we have memory. This is your memory. This is how we draw memory. Yeah? In the exam, you can do the same. Remember this diagram, how to draw memory. I have been telling this to all my diploma students. Just draw like a box, put a few stack, put a few lines like that. That's how we draw memory. And this A is one stack, one so-called one program. B is another program. Then you can, have many blocks because memory is all made of blocks. That's why we call memory block. Then we have a register. Where is the register? Nearby the CPU. Registers are always located nearby the CPU. So you have a PC, program counter. So the program counter points to a current instruction, so one line over here, PC. Remember the PC will remember what is the line number, program line number to, to do something next. Okay, then move to point number two. When the interrupt is received by the CPU, remember, the interrupt will receive by the CU, more specifically by the control unit, which is inside the CPU. The current instruction is completed. All the registers are safe in the stack area. The PCB, remember the process control block? The PCB must remember which registers, what is the request. Then the PC is loaded with the starting location of the program B. B. Now the instruction here tells you uh, link to program B and do something, for example. So the PC is loaded with starting location of program B, which is the interrupt handler program. The interrupt handler program understand. Now I need to branch out from A to B, for example. That's what the instruction is in the PCB. So this information also will be recorded into the PCB because you need to return. You need to come back to A. Once finished with B, you need to come back to A. This causes a jump to B, which becomes the executing program. So now program A is trying to execute program B. So the PC will update that information. Everything is being kept in the PCB as well. So now what is the instruction? The program A need to execute program B. All this information need to be kept in the PCB so that the program flow understand once the program B is finished executing, need to come back to A. Otherwise, it will be hanging, don't know where to go. It will not be properly terminated or ended. Okay, let's continue. Now A is requesting to run B. When the interrupt routine is complete, that is B is complete, the registers are restored, including the program counter. The original program resume exactly where it left off. You see? So when B is run, end of B, the return will be back to PC. So the PC, the PCB block, the PC will be updated. A, I'm done with the job B, and I'm coming back to my original program. So it comes back to program A. Then the PC and the registers and the PCB block, everything will be updated. This is a simple example how a service is being interrupted. In other words, how A is being interrupted to run B, do the job in B, and return back the control to A. As simple as that. So you can draw these three diagrams, and you don't have to remember all these long statements. Just explain like what I have just told you. There is a request from program A to run program B, execute program B, complete the job in program B. Once finished, return the control to program A. And along the way, the PC, the registers, the PCB block will be updated accordingly so that the entire operation is running smoothly. That's how you explain, very general. And if you can do that, if you can draw this three diagram, explain that, I hopefully believe that you will get almost full mark for that question. Remember guys, student, all your exam questions will be picked up from your lecture notes. Very few or very small number of questions here will be picked up from the outside your syllabus. That is another good thing about this subject, this lecturer. He always points back everything to his notes as well as the tutorial. I don't know about Penang and Subang. The tutorials are very important. We are doing tutorial 4 right now with the KL group. I provided all the answers. I'll be uploading that as well in Blackboard, just in case Penang and Subang. I'm very sure your tutor will have that. So the answers for the tutorials are very important. Yeah, please request from your local tutor to run all the tutorial classes because I've seen many times. I'm very sure your local tutor also understand that very well. That this lecturer, give me a minute. Mala, good morning. I have a class, Mala. I'll call you back later. I understand this lecturer very well. That's a good thing about him. He will pick up questions from the tutorial as well as from the lecture note. Okay, guys, I know this is a bit dry and a bit too technical, but for those who understand, this is quite interesting. Any question before I move on?
Yes, I have one.
Yes, please.
The program counter points to current instruction. Does it mean by registration?
What is your last statement?
Sorry, statement.
Your PC connect to the current instruction, then
Current instructions.
no. Repeat your question. I didn't get your last line.
Uh, the program counter points to the current instructions. What does it mean? Is
Oh, okay.
by
Okay.
registration?
All right. For example, in program A, look at my mouse. Program A, let's say you have 20 lines. 20 lines, and the PC refer to the current instruction mean maybe line 18. That's the meaning. So line 18, what the line 18 tells, branch out to program B, line 10, for example. That is the meaning. Current instruction means one particular line in your current program A. Understand?
So the memory,
In the memory, yes. Because
memory.
now you have a program A. For example, program A sort 3 numbers, and your program is 20 lines, for example. So the PC in your registers, PC is also a registers, right? PC will remember all your line. Where is your flow now? At line 17. When the PC go to line 18, the PC understand I'm at line 18 now in your program, in your memory. And then the line 18 tells the function of the line 18 is if condition is X, for example, X is greater than 0, branch out or go to or execute. It depends on your language, how you write. Execute to program or subroutine B, line 10. That's what it does. So this line here, line 18 will branch out to B. That is the meaning of this whole statements.
Oh, this is similar to the little computer.
Yes, yes, yes.
Thank you.
Understand, huh? Okay. Any other question, guys? That's a good question. Clear anything, huh? Don't think that, oh, because I was a student before for many, many years. Sometimes we tell ourselves, it's okay, I'll check later, I'll read through the notes later. But don't run into that mood, because then you stack up too many questions in your brain, but then you got no time to ask, because we have so many things to learn. When you stack up, you'll forget the current question. So the good thing is like your friend, you don't understand anything, ask immediately. Clear your doubts. All right, guy. With that advice, any other question? Okay, looks like no.
No,
No
no.
questions for now.
Okay, don't execute me. Don't execute me to ask question. All right, let me move on. Use of interrupt. Okay, we have real-time or time-sensitive interrupt, which we discussed some on Tuesday. And some of you managed to give some example, like real-time interrupt is happening at that moment, like what I'm doing now. This is real time. I'm interrupting now. So this is an example of real time. Or whenever I press any button, like this, escape. This is a real time interrupt. All these are real time interrupt to my system now. When I switch screen using my mouse, okay, let's see. All of you can see what I'm doing, right? This is real time interrupt. Each one of my action is an interrupt to the OS. Otherwise, the OS will just wait for me, listening all the time. We call that listening, isn't it? Okay, what the user wants. So I can interrupt at any time that I want. All these are real-time interrupt. But we do have what we call time-sensitive interrupt, like what we shared on Tuesday. Many of you managed to give me example. Okay, let me see whether you are with me or not. Type again. What are the time-sensitive interrupt? Type here again. I know most of you did very well on Tuesday. What is time-based interrupt or time-sensitive interrupt? Type at the chat now, I can see, and you can see as well because my screen is shared. To make sure that you guys are with me, 60 of you. Today I don't have 60 of you. I have maybe 40
Time-based
plus, 15
interrupt.
plus. Okay. Jivanes, I see you have typed message. Yeah, alarm. Alarm. Okay. Leong alarm. Be more specific. What alarm? Are you referring to your phone or to PC, laptop? PC timer. Okay. Phone alarm. Okay. Brian. All right. Anyone else? Other activities. Calendar reminder. Very good. What else? What else? Guys, there are 60 of you. I need 60 different answers in your exam. I don't want all of you to write the same thing. Boring for me to mark. Huh? Think something different. What else? I did mention a few during Tuesday. What else? What else? Let's cover at least 7 to 8 different activities. Time sensitivity. Windows update reminder. Okay, good. Patch update. Patch update. What else? There are many more. Many more. I want all of you to behave like an IT student. You guys are going to be an engineer very soon. You need to graduate as an engineer, not as a ordinary IT executive. I know some of you will be ended up working in Intel, in Motorola, in AMD, in Seagate, in Western Digital, in Itachi, in Silterra, in MEMC. I know many companies. I have been to many companies. Phone backup. Okay, good. What else? The rest of you, I see many of you are very purely you are a passenger. I don't want passenger here. I want leader. Passenger not so good. You passenger forever passenger. I want leader. Leader, come on, leaders. Type, type, type. What else? There are so many other activities. Time sensitivity. To make it more interesting, Kajendra, very good. Windows update reminder, OS update in smartphone. What else? Okay, move away from system, computer system. Think about, let me give you one industry, airline industry. Don't go very big about the airline system. Airline system, let's think about a plane. What a time sensitivity.
Sir, flight approaching reminder at airports.
Right. Keen, so that all your friend can capture. Let's think about a plane. A plane is flying real time, right? Plane is flying real time. What are the time sensitivity activity or time sensitivity, what we call uh, signals or events? Event is the right. Flight approaching reminder at terminal. That is okay, time sensitivity. The flight controller, what we call the terminal controller or the flight controller, knows exactly which minute the flight will be landing. Flight delay notice, yes, but that flight delay notice is time based, but it's not real time. Real time is something happening at that particular time. Okay, that's okay, accepted. It's a time sensitivity activity. I want more challenging, more real time, more risky. Flight real, okay, time traffic line notification. Okay, good. This real time traffic line notification is, it tells you where is your plane at that moment, isn't it? Okay, that's good. Scheduler reminder, okay. Why? Okay, I don't know what happened to NU Stan. Left the chat. Maybe he's having, that is also a kind of interrupt. He requests for quick and then he might join back. That is also an interrupt. but not time-based lah. This is a e-request. All right, guys, what else? Think. Real-time, time sensitivity, interrupt, or request for the plane. For the plane. Come on. That's all. You want to work in an airline industry or not? I'm very sure. GPS, definitely, yes. GPS, no question about it. GPS is real time. The coordination of the plane is all time based. At that particular moment, at that particular minute, at that particular second, where is the plane? What is the altitude and attitude, right? That is very important. Runaway error update to the pilot before landing. Okay, fine. That is just an event, not time sensitivity. That could be an what we call request. LRT train scheduler, fine. Weather forecast, okay, fine. Okay, coming back to the plane, when plane is flying, when the plane is flying, okay, very good. The car providing signal when we are reversing, yes, but that is not time-based, it's just an real-time event, real-time event. Weather forecast, it can be real-time, it can be for future, also time-based, time-based. All right, coming back to the plane, when the plane is flying in a flying mode, especially when the plane is in a auto mode, the plane will continuously communicate with the controller, with the control room, to make sure the plane is in auto mode, at that particular moment and minute and second. And the plane also will check the GPS, yes, that's correct, to update where is the location of the plane. And also the plane will make sure the anti-collision system, meaning those who understand again, the plane will make sure that every plane is in a appropriate distance from other planes. We call that anti-collision system. So that the plane doesn't get collided or doesn't get knocked to each other. It's a real-time system, time-based or time sensitivity system. When a plane coming too near, they will signal each other, hey, I'm coming too close, go away. But this doesn't happen, but they will make sure every plane has its own route during the flight, the entire flight. But sometimes it do happen due to error, due to weather, due to miscalculation, due to human error. It does happen. But the system, the plane is built in with auto, what we call anti-collision system. And now the technology is being developed into what we call the smart car, driverless car. They are approaching, they are using the same technology so that when the driverless car, you see, in some countries we already have driverless car like Singapore. When the car drive on its own, the anti-collision system must be activated all the time so that it doesn't get collided, doesn't get in accident with other object. It's the same like your vacuum cleaner at home. It is built in with that system. Whenever it knocks a wall, it understands, hey, there is a wall there. I shouldn't be knocking it again and again. Anti-collision system, a very simple one. And the same thing is built in LRT. Remember in Cal, recently we had a case where two LRT collided. How could that happen if the anti-collision system is inactive? So why that thing happened, for those who are not very sure, because I'm in Cal, I know the one train is active, auto mode, the other train was in manual mode. The driver, remember, the driver of the other train He was driving in an opposite direction and it is completely manual. So this auto train detected the other train, but the other train did not detect this auto train. In this thing to happen, both the train must be in auto mode. Anti-collision system must be activated. If one is active, one is not active, not possible. Huh? So that's why the train got collided, got accident. So the manual train, too bad lah. The guy really out of his mind. Huh? First is offline. Second, he was driving on a different direction. Completely crazy guy. But if both trains happens to be in auto mode, completely auto collision system activated, this will never happen because they do testing all the time. Huh? There is a certain distance. I don't know what is the distance, but I know it's around 100 meters or 200 meters. Any object before the station, before the coach, any object, the train will stop automatically. That is how it is built. Huh? So that is what we call anti-collision system. Also kind of interrupt, time sensitivity or real-time interrupt. So guys, you guys are IT guys. Open up your thinking. Don't just think about IT system, PC. I'm sometimes too bad lah. Just think about PC alone. You guys got to even think about servers. We are not talking much about servers. I myself, I have handled hundreds of servers, you name it. So we have to give example when come to servers, Windows servers, Linux servers, Unix servers, QNX servers, yeah, iOS servers, Android servers. Think about all the servers, huh? Don't just think or restrict our thinking only to PC base. Then you'll become only PC support. Because I know most of you will be ended up working in good companies, either in Klang Valley or in Penang. In Penang, I know most of the companies in Penang, also in Klang Valley. So I have many students working in good companies besides software development companies. So you got to open up your thinking, your way of thinking, your examples. Only then you have a lot of things to talk during your interview. I can share a lot of things with you guys, unless you guys not interested. During the interview, you have to talk. You conquer the entire conversation. Don't wait for your interviewer ask you a question. Just talk until they stop you. If you do that, but of course your talking cannot be nonsense, all with facts, with examples, with real things, with your experience, definitely they will hire you. They will be telling you this is the candidate that I'm looking for. But if you just wait for them to ask you a question and your answers is so short, then it is clearly saying that you are not good, not the candidate they're looking for. All right. So with that, let me move back to the lectures. Unless you guys have any question, Any question, guys? In another 2 minutes, we will take a short break and then I will continue again. All right, let me finish this slide before we take the break. Signal completion. I think I have spent like 10 minutes in that one line, real time or time sensitivity. Signal completion. Example given is printer ready or buffer full. Signal also is an interrupt. When the signal send you a signal, sorry, when the printer send you a signal, I'm running out of paper, that is an interrupt. Or when the printer telling you I'm ready, that is also an interrupt. Allocate CPU time. When the CPU tells you I have one request from another user, that is also an interrupt. So all these are interrupt. I think I've given you many examples of interrupt. Don't come back to me and tell I don't know what is interrupt. I don't know what is the example for interrupt. Please, if you are not very sure, please check with your local tutor. I've given you maybe 20, 30 examples of interrupt by now. Software interrupt, I've given you many examples. F1, F2, escape, alternate control, del, tap, all that are software interrupt. And it is very common when you write program, you'll build in all these interrupt so that you can do other tasks along the way. Okay, with that, before we discuss very specific example in the next couple of minutes, let's take a short break, 5 to 10 minutes break, huh? Because it's Friday morning. I don't want to overload all of you with too much of information. Let's get back at 10 minutes after 10, huh? 10 past 10. Okay, take a
Okay,
break.
sir.
Yep. Okay, let's continue. Let's continue. Okay, next what I'm going to do is I'm going to discuss a few example of handler interrupt or interrupt handler software, very specific example, such as what you all can see now. This is keyboard handler interrupt or keyboard interrupt handling software, how it functions. In other words, how the keyboard handles your requests. Using a keyboard handler interrupt. So when the interrupt occurs, that means when you press any key on the keyboard, for example, when you press escape key or when you press tab, tab alternate key, uh, that means there is a request coming in, right? You are making a request. So any current program, like now you see here, for example, this slide, I'm displaying this slide. So this slide display is the current program. Original program executing is this slide. So when I press the alternate tab button, this current program will be suspended. You see, when I do this, this slide will be suspended. That means this interrupt override. This interrupt override and this original program will be suspended. That is the meaning. That is the meaning. So the original program will be suspended, the interrupt will take over because the interrupt is having higher priority. So whatever I press, let's say alternate tab, right? That is my input character. It goes in as an input to the interrupt handler software. And then the software, this interrupt handler software will check what is the character that I press in, what is the keyboard button that I press in. Because remember, every keyboard button has a ASCII code. So if I press tab alternate, it will be converted into the ASCII code. What is the number? And if it is not a special character, and then it's resume the execution. That is, execute my request. But if it is a special character, for example, I press maybe uh, alternate control del, for example, that is a special character for the interrupt handler software, and then it will take action accordingly. As you all know, when I press control alternate del, that means shut down, isn't it? It will take the action accordingly. But if it is not a special character, just an ordinary F1 request, F2 request, then it will resume the execution. So once the execution is over, if you see here, then you'll come back to the original program. That's how it works. That's how it is also explained over here, right? The whole operation at very high level. So all the information, because the program must remember after I finish this interrupt, where to come back. Come back to this original program, isn't it? All the details will be kept in the PCB, process control block, also in the PC, PC program counter under the control unit. So that's how keyboard handles every request from you. Because we are the one keying in keyboard. The same goes to your phone. The same goes to your server. That's how your system works. Okay, next. Printer handler interrupt. Almost the same. So original program executing. The original program could be the printer in ready mode, doing nothing, or the printer is printing something, doing some job, or scanning, or whatever it is. It depends on the printer, isn't it? If it is an ordinary printer, it does only one job at a time. But if it is a multi-function machine, like your photostat machine can do printing, can do scanning, can do faxing, can do sending email and receiving email, 4-in-1, isn't it? All the latest multifunction machine. So when the machine is doing something, normally it's very difficult to interrupt. Printer works slightly different from the system, computer system or keyboard, because the printer normally, if it starts something, it will try to finish it. That is a function of the printer. So that's the reason why printer is built in with what we call spooling or buffer. It keep all the requests. Whoever make a request to print, it will store into the buffer spooling system, and it execute according to the request basis. First come, first serve, because printer can do only one job at a time. So let's say the printer is printing a job now, and then there is a request. So if it can be definitely the printer will finish the printing first before continue the next interrupt. But let's say it's not a printing request. Let's say it's like off the printer, or you open the cover, yeah, something like that, something very extreme. Yeah, then the current activity will be suspended. Yeah, especially if you open the cover or you press the hold button, for example, the current operation will be suspended. That is how it is explained. That's how it's operate.
Sir,
So yeah,
I have some questions.
yes.
This suspense, how does it suspend itself? Where
It
does it?
holds. It's halt. For example, not printing job. Printing job. Remember, I told you it will finish it. But for example, uh, if scanning, for example, scanning, maybe the scanning will be on hold. That is what we call suspend. Until it does the higher priority job, complete the higher priority job, then it will continue. On hold, on hold. Suspend means on hold. Not terminated. It cannot be terminated. Just on hold. It's like your washing machine. You can hold, and then you can top up with your detergent, top up with your soap, then you can press continue again. That's how it works. That is the meaning of suspend. The same goes to any of your program. You can hold it like your phone. You can do recording, then you hold for a while, you do other things, and then you continue. And then while you're talking, you have call comes in, you can hold the other call, you talk with the receive the new call, and then you continue back with the old call. And that is all what we call suspend or on hold. Which program handle that hold is all the handler, the interrupt handler software. So when the interrupt handler holds that, it keep that numbers, it keep that interrupt inside the PC, inside the program controller, which is also in the PCB. That's why if you see task manager, let me show you task manager for a while. You see some programs here stop, some running. So you remember, some will be suspend. You can suspend if you want. You see, you can start, stop, restart, open services, search, and go to detail, things like that. So you can have some option to stop. To stop means to suspend. But dangerous lah. Don't simply stop. You must know what you're going to stop. So those system administrator, they understand every single process here. This is PCB block. This is PCB block. So you as a system administrator, you need to know all this, each one. After some time, you will be very familiar. For example, like AnyDesk, isn't it? My apps AnyDesk is running now. I'm very sure I can stop this if I want. I can stop, I can restart, I can open services and so on. And I also can go to the details, something like that. You see, I know the AnyDesk is running. So if you know the process, you can request to stop. That is the function of the interrupt handler. If you're not very sure, don't do lah. You see, there's a one suspended process here. Background task host suspended by myself, for example. So this is what we call suspend. That means on hold. What I can do next, if you right click, you can end task, end process, provide feedback, set priority. Right now the priority is normal. I can change to high. If I change to high, what will happen? It will run because higher priority, isn't it? Just because it is normal priority now, we on hold it. So you have a lot of options that you can do. Yeah. And you will see the thing change all the time, because it's real time. It's real time. You see the suspended is already gone. So that's how it works. I hope it gives you some understanding. There are hundreds of processes are running. This is just one example. Good question. At least it helps you to understand better. Don't simply accept any word here. You must understand. So in this case, the current process is on hold or suspended. The new process or the new request will be handled. And then fill printer buffer and then resume the old work. More to print, yes, continue. If no, stop. For example, this is how the printer handle every request or every interrupt. Any question, guys, on printer?
No.
No questions for now.
All right.
No questions.
Okay, let me continue with the next slide. Using an interrupt for time sharing. This is when you have more than one request. You have, let me explain first. Time sharing, I hope all of you understand what it means by time sharing. In a multi-user environment, when there are more than one users, meaning when there is a more than one program need to be executed, in an environment where you have only one CPU, like your PC, if there are two users or two jobs that you need to do, you only can run one at a time. You need to suspend the other program, isn't it? For example, the PC now, I only can display the PowerPoint. If I want to display something else, I need to interrupt. So let's say I want to display my Windows. I want to display my meetings now. I have to interrupt my display. That's what I did. I only can show one at a time. I'll go back to my display. See? So what is program one? Program one is this display, PowerPoint display. What is program two? Before I go to program two, I tell my OS, Windows, Hey, I'm making a request. Huh? Stop your program 1, stop your displaying. Let my program 2 run. Select next program. My next program is program 2. That is my meeting minute, my meeting. So the OS understand I'm making the request. So it will resume the program 2 for me. And then once I'm done with program 2, I hold because there is another request. Go back to the display. So the clock will suspend or hold my meeting display and come back to this program 1. Yeah. So I can switch. So this is what we call time sharing. Time sharing meaning not at the same time, but at different time, I display different program because the time is running, isn't it? It cannot be the same time. The time that I run this and the time that I run this are two different times. So two different clock interrupt. I hope all of you understand how this diagram need to be explained. Any question?
How does the time sharing do?
How do you? Again, your question, please. Hello, who was that?
Sorry, I just mute.
Oh, okay. What is your question?
My question is, how does the time sharing does do?
Time sharing.
Yes.
Okay. Time sharing means we have one CPU that we share the time. That is the meaning of time sharing. One CPU but shared by many programs. That is what we call time sharing. So here in this case, you have one CPU, one clock, but being shared by two programs. You take 2 seconds, I take 2 seconds. That's the meaning of time sharing. Yeah, that is the meaning of the terminology, time sharing. One CPU we share by two different users or by two different programs. It will be slightly different at the server environment where you have more than one server. The time sharing in the server will be slightly different. If there are two servers or two CPUs, then the two program will use two different CPUs. So no so-called time sharing because every CPU is dedicated to one program. That is not time sharing. But in the case of PC, where there is only one CPU, the program only can share the CPU time. That means I allocate you 2 seconds. After you are done with your job, I'll occupy the CPU for 2 seconds. That is what we call time sharing. Okay, I hope you understand that. That is what we call time sharing in a single CPU-based environment.
Okay, understand.
Okay, let's move on. Interrupt processing method. Two questions must be answered when interrupt occurs. If there are other interrupts already waiting for service, how does the computer determine the order in which interrupts get service? Okay, who can answer this question? I want all of you to answer these two questions. Let me read the two questions for you and I want to get an answer for you. Type 1, what is the answer? You type 2, what is the answer? If there are other interrupts already waiting service, how does the computer determine the order in which the interrupts get service? Question number 1. Question number 2, how does the computer identify the interrupting device? How does the computer identify the interrupting device? Okay, let me go back to the meeting and I want to see your answers. Type. Okay, good. Okay, I want to see more names now. Type. Don't just keep quiet. Answer. Type question 1, answer. Question 2, answer. If you don't know, type don't know. It's okay. Guys, so far I don't see anything. Type your answers. Hello. You know or you don't know the answers. Type something. Type something. I can help.
Okay.
But don't keep quiet, huh? When you
But
keep
we're
quiet,
still
I cannot.
typing. Gives
Huh?
us some time.
Again? You need time? Okay, never mind. Think about it. I'm waiting. Okay, guys, I see only one feedback so far. Thank you very much to Leong. I hope all of you can see, because my screen is shut. When another interrupt is awaiting in service, the computer will complete second interrupt before continuing the first interrupt. Okay, but the question, let me go back to the question. How does the computer determine the order in which the interrupts get service? The answer should be very short. And then second, how does the computer identifying the interrupt devices? I have
I just wrote the
explained
second one.
I have explained all this in my lectures, in my during my presentation. So first answer, what is the first answer? Number 2, the computer identify. Wait, let me see. There are more messages here. The computer identify the interrupting device by sending a special code to the processor over the bus. Yeah, but I'm not saying it is wrong, but there is you have to be very specific. Huh? Special code. What is the name of the special code? The computer interrupts are determined by priority. Yes, you are right. Priority is the answer. Huh? Answer number one is priority, based on priority. So I don't know who is this guy. Kai Lin Ho. Kai Lin Ho, you got it correct. Interrupt service is based on priority. Higher priority, higher service. It's like first come, first serve. Huh? Higher priority, first come, first serve with higher priority. If your priority is not high, you remember I showed you one example just now. One of the program got suspended because it was normal. But the moment you change to high, it will run. The serve will wait the program by user to interrupt. Okay, but it all depends on priority. Huh? Okay, interrupt is a signal which sent from device or from software to the operating system. That is correct. But what is the name of the you know name of the name of the device, right? Interrupting device. How does the computer identify the interrupting device? It's based on the device interrupting device number. Remember? IRQ what? 1, 2, 3, 4 numbers, isn't it? Number 1 to number 32. Remember I showed you here in the slide? There. IRQ 0 to IRQ 31. Interrupting lines or interrupting ID. Every request, let's say printer is requesting, printer will have its own number so that the OS knows, hey, this interrupt is coming from printer. You think what? OS got a brain? OS got no brain. OS has to identify everything by number. In operating system, in computer system, everything is number. The system doesn't understand anything else beside number. Remember, I'm telling you this from day one. The computer system only understands 1 and 0, nothing else. Everything need to be converted back to 1 and 0. In fact, if you ask me, not even 1 and 0. Yes and no. If there is a signal, current, the system will understand I got to do something. If there is no current, the system will not do anything. End of the day is 1 and 0. 1 and 0 translated into there is a current, there is a pulse, there is a signal or no. That's how computer system works. Why they give a number? Because the number will be converted into a ASCII code and then the system will understand. This interrupt is coming from printer. This interrupt is coming from keyboard. This interrupt is coming from a user. So answer for question 1 is priority number. Answer for question number 2 is the interrupt number. Interrupt device number. Okay, so that normally this kind of question will be asked in section A. Section A, you will have 20 multiple choice question. Section A of your OS, NOS will have 20 multiple question, multiple choice. So this kind of question will answer in multiple choice. I have many students now will obtain 20 out of 20 because they are so good at it. And normally I will go through 2 to 3 years passive question with them. And the question repeat. Okay, I'm going to continue with next slide. I have 20 minutes before I finish for today. Vector interrupt. Vector interrupt refers to the address of interrupting device requesting for additional hardware to implement. So to do vectored interrupt, you got to install additional hardware. Vectored interrupt is like a properly structured or managed interrupt. Of course, it requires additional hardware. Polling, I did explain to you. Identifying interrupts device by polling each device. General interrupt is shared by all devices. Yeah, so polling is like a process of putting you in a buffer, in a waiting list. Like when you go for election, they ask you to queue up. That is polling. When it comes to your turn, you go and do your job. You go and do your selection. Otherwise, you wait because you are given a priority. You follow your priority, number one, number two, number three. This is what is happening actually to printer. You will be given a job number one, job number two. So you just wait for your turn, and that is polling. So all these are terminology that being used for interrupt processing method. Vector interrupt, an example. This is the memory. You have interrupt of address A, interrupt of address B, two different interrupt. And then all of a sudden the new interrupt comes in address of interrupt K. When interrupt of K comes in, it's requesting for a branch out to service the subroutine of K, for example. Then after finish with K, the interrupt will be returned back to over here, the last position. Normally it will come back to last where it stops before it start this. If B was the last one, it will go back to the B. If A is the last one, it will go back to A. That's how it depends. So it depends on the vector. Vector means numbers. Numbers. Where these numbers will be kept? Remember the PC and the PCB block. Program counter and program control block. Memory. Poll interrupt also handles by memory. General interrupt polling routine. Interrupt comes in, jump to a new request, perform the request, finish, return the request. Yeah, it's the same. So vectored and pool almost the same. This is more general. Vectored is more specific. So in order to do vectored, you need additional hardware, like a gaming station. Remember, when you do gaming, you can play within multiple users from different station. So when you do gaming and you want to play with multiple users, you need additional hardware. You cannot just play in one screen. You need additional screen, and the system OS must understand all the different machine going to join the game. That is what we call additional hardware. Remember, when you go to game arcade, you want to play, for example, the car racing among 3 or 4 of you. So the software must understand who are the people joining the queue. That is vectored. Pool is the same device, but being managed or being shared by many users, like printer. You send many jobs to the same device. That is pool. Vectored is where you have additional hardware. You have 2 display, 3 display. When you go for a shopping complex, you see sometimes they use 20 display to display the screen, one screen. That is vectored. So I hope you can see the difference. When we use many devices to display one screen, that is vectored. But when you use same device to do many jobs, you call that pole interrupt. So there is a clear difference. I hope you understand that. Vector is more complicated. That's why you need additional hardware, and the software must be capable to handle all the devices to display that one single screen or display. But you use multiple display, for example. Multiple interrupt example. So we have discussed two earlier, but if you have more, all the same, all the same. You just continue with more. So let me run through this quickly before we stop for today. You have original program running, and then interrupt comes in. So you suspend or on hold the current program. You execute A. Once you finish with A, or even halfway, there is another interrupt coming in. Interrupt B comes in. So you suspend A as well. Go and run B. Why? B has higher priority than A. Remember, you run B only when it is higher priority than A. Then you run with B, B completed. You go back to the previous program, which is A, not original A. So you run A, then you see C coming in. C having higher priority than A. So you suspend A and you run C. Completed, you come back and run A and finish it. Completed, you end the whole thing and you run your original program. So that's how it works. So it can be one program, two program, three program, hundreds of program. The scenario is the same. Guys, all of you need to understand this very clearly. Same like I have just explained. It's all based on priority. The answer is priority, and next the answer is based on interrupt numbers A, B, or C. And interrupt A will have its own ID, interrupt B will have its own ID, interrupt C will have its own ID. Okay? Any question, guys?
No questions.
All right, good.
So far, okay, sir.
All right, thank you. Let me continue. The same controller, we already talked about the controllers. I'm not going to repeat. Every device will have its own controller. We call I/O controller. Using multiple I/O controllers, I think I've explained all this very much earlier. Multiple interrupt will use multiple I/O controller. For example, we have controller for processor, we have controller for memory, we have controller for hard disk. If you check your device manager in your own system, there will be many controllers. These controllers are a piece of hardware card that you inserted into your CPU, but it is loaded with software programs, loaded with software program. And that software program works very well with CPU or communicate all the time with control unit. All right, with that, I think I will stop our session today. And I would like to check with all of you if there is anything else that you're not very clear on this topic, interrupt. So far, I find interrupt is the so-called the topic that we discuss in quite lengthy, almost 2 lectures. So what it tells you it is quite important. All of you need to understand interrupt very well. In fact, in our diploma program, I still remember we discussed interrupt in slightly detail, quite detailed. For example, we have mechanism like first in, first come, or first in, first serve. What it tells you? It tells you whichever job or request comes first, you handle first. For example, if I ask open the Excel file first, so the system will open the Excel file for you. Then I make a second request. open the Word file, my second request. So based on request, first come, first serve. Then there is another mechanism, also how the OS works, what we call uh, like shortest time first. Whichever job takes shortest time to finish, the OS will try to finish it first. That is shortest time algorithm or mechanism. Let's say there are two jobs. One job requires 10 minutes. The other job requires maybe 2 seconds. The OS is smart enough to do the 2 second job. Why you let the 2 second job wait for 10 minutes? So the OS is smart enough will do the 2 second job first before go and execute the 10-minute jobs. That is another mechanism where how the CPU works. There are many mechanisms that we have covered in the diploma level. Then there is another mechanism what we call shortest time to end the job, for example. Yeah. So maybe it is a bit confusing for you now, but if you go and take a look at all the diploma notes, you will understand there are various mechanisms that we have covered, how the OS handle every single job. Shortest time left or shortest time to complete, for example. So for example, there are 2 or 3 jobs. One job requires 5 minutes to finish. Another job requires uh, 10 seconds to finish. Another job requires 5 seconds to finish. The OS is smart enough to finish the 5 second job, then 10 second job, then the 10 minutes job. So that is another mechanism. So Microsoft is very smart. That's the reason why Bill Gates is still the richest man in this world. Bill Gates, as you all know, is the richest man in the world and is controlling the whole world now. He's one of the most powerful men now. For those guys who doesn't know, uh, he has built the software, Microsoft Windows, and is making tons of money out of this. And he's one of the richest men. He's the richest man in the world. And he has the most complicated, most used software in this world. That is Microsoft Windows. And this software is built by many different countries, by largest or huge number of people from all over the world, smartest people, and they have built in all this into the OS. So that's how your OS is working today. It is a very smart software. It is a very high-end, complicated software that you and me are using it today. Millions of people are using it today. And if you look into the detail, if you work for Microsoft later, of course, it's very difficult to get a position with Microsoft. You will understand how the OS is built. So it's very complicated and it has all the mechanism. It has all the algorithm built in to manage whatever situation. That's the reason why you see the OS today that we have, Windows 10, is so perfect. You don't run into any problem. It works so well. It has been there, what, since 2010? Already more than 10 years, isn't it? We are still using it. And everybody is happy with it. That's why we don't see or we don't need another OS for now. Microsoft is very happy with 2010 or Windows 10, and is doing his job very well. So why we need another OS? Unless, of course, Microsoft also has come out with other OS. For example, they have come out a new version for the tablet, for the server, for other devices. But for PC, I believe this is very good, and it's all the features. They just need to update some patches instead of changing the whole thing. Okay, with that, I'm going to stop my lesson today. It's going to be almost 11 o'clock. and I'll talk to all of you on Tuesday as normal. And if you have a tutor today, just continue with your local tutors. For KL student, like what I said, we only have lectures today, no local tutors, tutorial class today. So we will end the class at 11 o'clock. I'm going to stop the recording.